This is an integrated approach to defining solutions. It counts for AIA credits. It's in line with the Canon Design vision statement. Together we create design solutions to the greatest challenges facing our clients and society. And align with our code of conduct, integrity starts with us. We'll talk about the goals, objectives for the learning sessions today. As solutions are defined early in the design process, we want to describe kind of collaborative ideas that will aid us as we go forward and basically leverage the teamwork, the entities we have in the firm or with our outside partners. We want to describe the kind of questions that go along with that will help the integrated process and move forward the design. And then we want to explain why these questions are important to ask from the perspective of how they would affect the engineering design of high-performance building systems. And then finally, how those engineering design questions will have an effect on your architectural design decisions and vice versa, focusing on cost, space planning, constructability, and schedule.
Wow, we're going to do that in 20 minutes?
Hope so.
Okay. So our scenario is that we are about to begin designing a project together. Troy, your friendly design leader, architect, and Patrick, our engineer, who is ornery engineer, who's leading this. Ornery already? We haven't even started the meeting. We haven't even had a meeting, and you're
ornery. I don't like Wednesdays.
Well, we could start on not a Monday. We'll start on a Friday. That'll make everybody happy.
It's ideal.
Yeah. So we've already got the goals for the project established, and we're starting to think about taking the program for the building. We have a basic, what probably in healthcare we'd call it a key room program. It's developed enough so that it has a grossing factor to it. So we have some sense of how much MEP space is being allotted for in the budget right now, which has probably already been developed at a square foot level of detail. And we're sitting down and really strategizing about how are we going to take the priorities that are reflected in the basis of design and start to convert that into a physical block and stack for the project, right? How are we going to start to mass up this project and get away from spreadsheets and into actual architecture? The last session that you had on this topic, I believe they had completed an OPR, right? That should have hopefully included a program, a cost model, some basic goals of the project, such as the durability of the project, the hours of operation, some very basic energy objectives like BTU square foot per year, so overall energy targets, and there should be some kind of a site analysis completed by now. So the question is, approaching a block and stack for the building, where do we get started?
Yeah, show me what you got. What do you have for me, Troy?
Well, it's a hospital project. It's going to have beds. It's going to have a central utility plant. It's going to have a diagnostic and treatment base. Sound familiar?
Slightly.
There's an ambulatory component to it. It's basically the last three projects we've had in the studio here in Chicago. So I think the first point we want to make is that you're probably starting off with the first thing I said, a program, right?
Yep.
So what are we looking for in the program?
Well, what do I care about? Where does my stuff go? Do I have any room for engineering stuff? Do
It's
I have
all
any
our
mechanical
stuff.
rooms?
We are stuff. It's not us and we and they. It's
you have a
and
lot
I
more
together.
You have a lot more space than I do. So how little space do I have?
Well, you've got 15% of the space, actually.
That's not going to work.
It's not going to work. Well, it's the program that we got, right? We got a program. It's 85% department stuff and 15% grossing. Is that a problem?
Slightly. Limits a little bit of what we can do, but I guess we can start talking through it. How do we get to a program and mechanical space option that works? So let's start talking about where we can put stuff and what we can do to shrink it.
So yeah, I guess the question would be, our experience, right, would be we want to be closer to like 30%. So 1.3, 1.225, 1.15 is a pretty tough grossing factor. So what if we can't change that? What if we, as you're saying, got to keep it really low, like a 15%? Is there a way that we can shrink MEP spaces and still hit the performance goals for the project?
There's always a way you can. The biggest component of space for those utility calculations is obviously mechanical rooms, and the biggest component for mechanical rooms is air handling units, especially for healthcare because they have such high air change rate requirements. So basically we start talking about incredibly shrinking rooms where basically if I can put together a system that instead of moving 8 air changes per hour does 4 air changes per hour, I cut my air handler in half, which means I cut my size of my mechanical rooms in half.
So you're saying that the grossing factor just affected air changes in the building because of the space for it?
Yep.
but that I can actually shrink some of the mechanical spaces if I'm willing to go down in air rates, air changes.
Yep, which means you got to talk to your client, you got to talk to your local, and you got to look at something, either fan coils or chill beams, some kind of additional cooling that'll let you reduce the amount of air you're moving around the building.
Does it matter where the functions are? Can I put them closer? Like if I get the fans closer to the surgery, for example, where there's lots of air changes and I can't throttle back the number because it's required by code?
It's going to help you with distribution, ductwork primarily above the ceiling, but it won't help you reduce space. I mean, ultimately, the air handler size is the air handler size based on where you're going to go, but as you're moving air around the building, if your ducts get bigger or smaller, it's going to be harder to coordinate. The big benefit for such a thing as the surgery room is if you have high air changes route for your operating rooms, your surgical suites, if you can drop straight down, it's obviously much easier to coordinate and much easier to lay out the footprint of pieces of equipment because we don't have to get as creative with how ducts get in and out.
So one of the early discussions we should have as architect and engineer, respectively, is to figure out not just how much space, but where the space should be in the stack in relative to even the grossing factor and the cost of the project, because those will have a direct impact.
So for instance, whenever we lay out a mechanical room for a hospital or really any type of building, one of the first options to come up is, can we put a penthouse on the roof? Can we just put it on the top of our stack, which makes sense from an operations perspective because that means the penthouse tends to be less usable space, so maybe it's not fully conditioned or maybe the walls aren't, you obviously don't have a lot of windows, so it's cheaper to build. The problem with that is most of your healthcare clients, they build one thing and then say they want to expand it 3 stories up 15 years from now or 20 years from now. It's awfully hard to expand a building around a mechanical penthouse, whether it's full size or a partial size. The other issue is people would say, well, you could put it in the basement. That's obviously a non-starter for most healthcare because I can't pull my fresh air from the lower level or from a tunnel to supply. So then you start looking at areas like where you have in this drawing option B, where it's, is there a sidecar solution where I can put an air handling system close to my highest needs without creating a lot of expensive footprint that I have to build and without impacting expansion in the future.
Yeah, vertical expansion comes up in every project, and usually we don't end up doing it in healthcare, but a lot of clients still want it as an option in the future. So being able to eliminate something like a vertical expansion may have an impact on the cost of the project, the distances that we have to run the ducts, so the drops and all that stuff. So it's good really right up front to talk to them about expansion, right?
Yep.
And get them to be real about it because they tend to want everything. That's kind of the client MO sometimes.
Yeah, no one wants to be the architect that built a $200 million bed tower or ED expansion where they said, I'm really glad these guys didn't let me expand it 15 years from now because they built me into this footprint. Everybody wants to get the next job in addition to do a great job on this one.
Okay, so I think the next topic is once we've got some idea of the massing, about our balance, right, between where the equipment is, the size that it has to be, a reasonable grossing factor, maybe somewhere in between where we started and what the owner wanted. We have to talk about floor-to-floor heights because that's usually the next big thing when we talk about loads on the envelope is how much glass there is and what those heights are. So as I look at the floor-to-floor heights, and the users generally want lots of glass in the building. We love daylight, don't we?
Yes, you do. But it has an impact on us. The more glasses, the more thermal loads. Hospitals tend to be cooling dominated just because they're so internal loading. So the issue is more cooling means more air, which means more ducts. Even if we went with a chill beam system to reduce some of the air, we'd have the same issue, which means lower ceilings because I got to run the ducts somewhere, which means then less glass because I have to pull the glass back. So there's a balance between the two that we start to run into.
So the architects and sometimes the users really want to push the ceiling up and squeeze the plenum and get that plenum as small as possible, which creates kind of a Swiss watch sometimes above the ceiling. So then the next option becomes adjusting the floor-to-floor height and making the floor-to-floor really high.
Yep.
And that jacks up the costs. So now the owner's getting upset because they're seeing the cost estimates rise because they have these really high floor-to-floor heights. So the solution has to be some kind of balance. So how do we strike the balance between space above the ceiling, the distance from floor to floor, and the amount of glass that we get in the building?
And when we start with glass, it always becomes a cost first. It's always a simple way that a contractor looks at a building and says, what's the glazing percentage, and puts a dollar figure on it. So we usually start with that 40% glazing as our kind of starting ratio. And that's where you don't really want to go above it because you're going to have cost model issues and you're going to have HVAC issues fitting stuff. And obviously, there's a threshold where you want to go below it, where you're going to have a building owner that says, yes, I love the cost estimate you've given me. I just hate the building because I have to work this. So that's where you start. And then basically what you start doing is you start moving from the outside to the inside. And the outside, we obviously like as high ceilings as possible. And you want to minimize that floor-to-floor while maximizing that glazing. But that means that you're going to need to move more air, which means you're going to need to drop the ceilings on the inside. So you can have a perimeter where you have more glazing and an interior. Now, the biggest effect that we have actually when we start talking about floor-to-floor and ceiling heights is usually sanitary lines. Toilets in your...
Toilets. That's where you go. When we're talking about how much glass are in the building, you go to the potties.
Toilets in your building type, since for some reason you typically put them everywhere instead of stacking them all in one place.
Gravity.
It's all gravity basically going downhill, which means it's all going to slope at least 1/8 of an inch per foot, which means those large 4, 6, 8-inch mains have to run above the pipes and go all over your building. So what we say to people is, if at minimum you can stack 40 to 50% of your toilets and limit the amount of runs I have to do that, that lets you hit your floor-to-floor heights, that lets you hit your 13 feet, that lets you hit your plenums. And that's a good place to start. So stack your toilets.
This is fantastic. So this is one of those things that if we talk to each other early enough and deeply enough, we could figure out that there are certain plumbing risers that if they can be accommodated, like stacking the toilets and doing other manipulations to the plan, I could actually get more ceiling height on the perimeter. I could get parts of the building that can have more glass and not increase the floor-to-floor height.
Absolutely.
So you create a Swiss watch not necessarily in the ceiling, but in the actual vertical circulation of the building and in the cores of the building, which is a lot easier to deal with as opposed to everywhere out the perimeter. That's awesome. So stacking 50% of the toilets reduces our plumbing drop requirements. So I think what we're saying is that there's a link between the cost, the floor-to-floor height, the MEP area, vis-a-vis the grossing factor we've talked about. We've talked about the areas depending on which system you select and how big the rooms are for that. And now for how you even run the cores and stack things, being able to have more light on the perimeter.
Which drives cost.
Which drives cost.